Hello everyone, my name is Zoe. I'm an application engineer at Central Innovation, and today my webinar is about what is a design table and how we can use them. So let's go and start to see what I will cover in today's webinar. Today I will cover that. I will show you that what is a design table, and then I will take you through two case study. One is a part and the other one is an assembly, to show you how we can use a design table in a part or an assembly. What is a design table? A design table is actually, it's a great way to, if you wanna create so many configuration of a parts or assembly. In fact, it's an embedded Excel worksheet which is saved with your model. So definitely, to be able to use a design table, you need to have a Microsoft Excel to be installed on your computer. And if you have a Microsoft Excel, you will be able to use to take advantage of the power and functionality of the Microsoft Excel to configure things like dimensions and feature suppression and so many other things. From now on, I will take you through the process of creating a design table using a part and then using an inside an assembly to see it in practice. For the part, first I will show you. This is a simple socket. It's a simple part. We're gonna start with a simple part, and then we will switch to a quite not very complex, but to an assembly which includes so many parts. And then, as you can see, this one is a very simple socket, and I will use a design table to configure and to make lots of configuration and different variation of this socket. So, but before that we start using the design table, I will take you through the model to introduce you some of the design intent in the model, and I will introduce some steps. I will perform some steps to make it easier to identify and control the specific dimension and features, and that I will work with in the design table. So through this model, we will learn how to set up the model effectively for the design table, and also we will understand some options when creating a design table. I will show you how we can add columns to a design table for additional dimension and features to use it for creating the configuration. And also I will show you how we can add rows to a design table for additional configurations to create. So let's go over SolidWorks, and then we can start with the part. I have opened the part. Before I go for inserting a design table, I want to show you a few things inside the part. First, let's have a look at the configuration manager section. And as you can see, at the moment, there is just one default configuration, nothing else. So if I go to the feature manager tree, you will see that. Let's have a look to see, before anything, let's have a look to see how this part is created. So I roll back to the cylinder. I can see that they have started with a simple cylinder using this sketch, and then there is a hexagonal cut up to almost some up to the middle almost of the cylinder to create this 6 point for the socket. And then using a circular pattern, they have created a 12-point socket, and using this code they have created this drive, and after that there is a chamfer. Okay, let's go back to 6 points. I'm going to take your attention to this part, to this section. First of all, if I show you this dimension, if I click on the dimension, you can see that this dimension has a different name. If you have a good experience with SolidWorks, you know that typically when we add a dimension inside the software, it's automatically named as, for example, D2 at sign X sketch1 or D1 at sign sketch1. But here, as you can see, this dimension has been renamed because there's a reason for that that you can see later on. So it is across flat. This is one of the dimension that I'm going to use. So I can keep it in mind that the name of this dimension is across flats. And the other thing is that I'm going to use is the diameter of the cylinder. Okay, the reason for this that as I change this dimension inside the design table, look, see what will happen if we change it here. If I change it to 6 to 5 dimension, point 625, you can see that how this wall thickness is getting narrower. Okay, so if I change it to 1 inch, you can see practically it's not applicable. This change is actually ruined the part. So we need to change our design intent, especially if we wanna keep Control Q. If we wanna keep the thickness of this wall as it is, okay? So I will address this problem inside the design table, and I will explain there what is my intention when I get to this point. So as you can see, I definitely need a solution to control the thickness of this wall when I increase the across flat dimension. So now there's no more thing that I want to refer here into the model, just 2 points which if we can change the name of the dimensions, it will be absolutely helpful when we want to indicate which dimension we are going to use inside the design table, which you will see in a few minutes. And the second thing that sometimes we need to change our design intent, meaning that as you could see, the thickness of the wall can be tricky here. If you increase the one of the dimension, this thickness will get narrower, and we will have some dimensions. For example, if you change the cross flat dimension to 1 inch or more, so in fact it is useless. So we're gonna address this problem in the design table as well. Let's go and start with the design table. To insert a design table, you can simply go to Insert. There's a section called Table where you can bring so many other tables to the part or assembly, but here I want to use the design table. When you want to create the design table, you can see there are different options. One is the blank option, auto create, and from the file. If you have already created a file before and now you're going to use it as your design table, you can simply browse it from using this option. But considering that the SolidWorks software is quite sensitive with the formatting that you use for the Excel spreadsheet, for the design table and any other table. So at this stage, I will stick to the auto create option because I want to deploy the SolidWorks format, automatic formatting for my design table. The next thing that I'm going to introduce you here is that how you can take control of your editing later on. If you have a design table and you have your model, if you select the first option, it gives you a, excuse me, give me a second. It gives you an opportunity of a bidirectional change possibility, meaning that if you select this option, you can change your dimensions used in the design table either through your model or through your design table. So it has a bidirectional effect. But if you want to block the editing from your model, you can go for this second option. In this case, you won't have a bidirectional effect and you just can do any change through the design table. So you won't be able to change the dimensions that you have indicated in your design table to be changed inside the SolidWorks. Definitely you need to do the changes through the um, Excel sheet format, Excel, or through the design table. So for now, I will use this bidirectional effect and I will click on OK. As you click on OK, you can see that it has been taken you through to the Excel environment, Microsoft Excel environment, and also there is a list of different dimensions here. Here is the place that you can see the effect of renaming your dimension. As you can see, it is much easier for me to decide or to see which dimension I'm going to select. If I have just this naming, like D2 at 12 point, you can see that how it is difficult for me to decide which dimensions I wanted. But here, I know that this is this dimension is the diameter of the cylinder, and also this dimension, this is the across flat that I'm going to choose. By keeping the control key, you can select as many as dimension you want. So I want the depth of the cylinder as well, but I won't select it now because I'm going to show you how later on I can add a column and select it from the graphical area. At this stage, I will stick to these two dimensions and click on OK. And when I selected the dimension, you could see that by default, some columns and some rows is added, okay? So now here I can move forward and out, add as many columns as I want and as many as rows that I want. Each row indicating, as you can see, default, indicating which configuration I wanna add. If I wanna add one more configuration, I will add one more row, okay? And in each column, I can add more dimensions or more features to take control of. So let's go at this stage. Let me tell you what sort of configurations I'm going to add. I want to have 6-point sockets and 12-point sockets. I want to have long sockets and short sockets. I want to have different version of these sockets with different across flat dimensions. So as you can see, there are so many configurations that I'm going to add. I will start by adding two more dimensions and features. First, let's go to annotations, and it put me back to the parts area, but doesn't matter. I can switch back to the design table. So here I will show the feature dimension, and I will go back to the configuration and I will edit this table. Again, it will take me to my design table. Just dismiss this pop-up. So, and at this stage, I'm going to add this dimension because it within this dimension, I can control the size of my short and long configurations, and also to be able to control the 6-point or 12-point configuration, I'm going to add this 12-point circular pattern feature. As you can see, it's added here. So now I will go and add the other thing that I'm going to address here. As you could see that the diameter of the cylinder needs to be changed according to the across flat dimension change, because it's indicating the wall thickness that I showed you. So here, instead of having one value, I'm going to change it to an equation. Again, as you can see, the functionality of the Microsoft Excel is really helpful here to for us to control our dimensions and features to create different configurations. So here I will create an equation, and this time instead of having a value, this equation can control the wall thickness. I would indicate that whatever the across flat dimension is, I'm going to add a 0.25 inches to that dimension, and it will create the cylinder diameter and consequently the thickness of the wall. So here I will go and add the different configuration. So let's make it a bit larger. Let's say 6. I will start naming the configuration 6-point socket, 6P socket short with the diameter with across flat dimension 0.5. So I will control this part with across flat dimension of 625, with across flat dimension of the 7.5, and with across flat dimension of 1 inch. Now I want all the same, but this time I'm going a 12-point socket. 12, 12, and 12. Okay. So for the next, for the first 4 configuration, I know the diameter of this one is 0.5. The across flat for the second one, it's 0.625. For this one is 0.75, and for this one is 1 inch. Okay, and I will use the Excel functionality to copy this equation across all of the for other configurations as well. So for as you know, this is a short one, so I will just copy it across on the whole configuration. And as you know, the same setting will be for the 12-point socket short version of the socket. So as you can see, I have the equation, everything is set. I need to copy this once. It was a mistake. So now I have short version of 6-point socket with different cross flat, short version of 12-point socket with different of the cross flat. The only setting that I need to add is the state of this circular pattern, which is the 12-point circular pattern for the 6-point and 12-point. As you know, the state of this feature for the 6-point is actually a suppressed one because it creates a 12-point. So for SolidWorks, the capital S is representing the suppressed state of the feature. So it will be the same for all the 6-point ones. And the capital U is indicating the unsuppressed state of the feature. So if I just put a U here, so it means the state of this feature for this configuration will be unsuppressed, okay? As you can see, up to now, I have introduced 8 different configuration for this socket. Now I'm going to add 8 more, and this time instead of short socket, I'm going to have a long one. Okay, simply instead of doing all of the steps once again, I can copy and paste the same 8 configurations, and everything else will be the same. The state of the feature in terms of being suppressed or unsuppressed is the same. So the only change that I need to take is that I take the length of the cylinder from 1 to 2, and this will be the length of the cylinder for all the long ones. And I need to change the name of the socket from short to long. So I simply copy this one and paste it for the rest of the. So at the moment, I have created 16 different variation of this socket, and if I just click anywhere inside the graphic area inside SolidWorks, you can see that the software is already created all of the configurations. And if I go to the configuration manager tree, you can see that all of them with the all specification that I wanted is added. So the crosshead is 0.5 inch. I have a 12-piece socket and it's a long one. If I come to the other end, you could see that it's a 6-point socket, the short one, excuse me, and the crosshead is 1 inch. So as you can see, how it is easy using the design table to create so many variation of the socket. Let me to go, I'm a bit in doubt about 12-point socket short one. I will go to the table once again and check the wall thickness. Just dismiss this pop-up. And then 12-piece socket short one. The equation is here. Not everything is fine. Maybe just it's a visual thing. So as you can see in how easy and fast you can add so many configuration to a part using the design table. And do you have any question to ask up to now? So you could see that how we can rename the dimensions to make it easier later on when we're gonna insert it to the design table. You could see how we can add the row and how we can add rows for adding configurations. Inside the design table, you could add column to add more features and dimensions to take control of them and do the setting for different configurations. So if you have any questions, please just put a message in the chat box and we can discuss it. If not, I can move forward and show you an assembly and how we can use a design table inside an assembly. Is there any question? So apparently everything is fine. I will move forward to an assembly and show you how you can, let's save this one, how we can use a design table inside the assembly. Let me open the assembly and I will move back. So as you can see in the design assembly design table, I'm going to show you that how we can use the design table. Excuse me, just give me a second. I'm going to show you how we can create a design table inside an assembly, and then I will use some functionality of the Microsoft Excel named data validation to restrict some values entered in the design table. And I will set some configuration properties to control new mates and components inside the design table. So let's move forward and we can see how it can be applied inside an assembly. So as you can see, this is a hand truck, okay? And what I'm going to add is I'm going to add different configurations to position this handle at different heights, okay? So to create this configuration, I need to find and figure out two things. First of all, how the position of this handle is controlled inside this assembly. And secondly, I need to see what sort of design intent I need to know to be able to control the position of the handle. So if I just get closer And if I highlight this handle, you can see there are some different holes. Okay, so and for different position of this handle, in fact, one of these holes should be in line with the hole of the lower, um, with this lower support, this support leg, to be able to fix it using these screws and nuts. Okay. To answer my question, I will go into the model and I will go over the handle to see first of all how the handle is control, the position of handle is controlled. So I will go to the mates, because typically we use mates to position the different parts together. Uh, so as you can see, there is a concentric mate, coincident mate, and distance mate. So the first two cannot, doesn't help me in terms of um, positioning the handle at different heights, but this time distance mate will help me so I can control this dimension to create different configuration for different position of the handle at different heights. The next thing that I'm going to figure out is that how this holes is made. As you can see, it's a simple cut extrude, and then using a linear pattern, if I double click on it, five different number of these holes have been linearly patterned upward with, and they are spaced 2 inch apart. Okay, so it is important to know that if I'm going to use that distance mate to control the position of the handle inside different configuration, definitely the change for these dimensions should be in 2 inches increments. Okay, otherwise, if any other change, if the change is less or more than 2 inches, it won't it it won't line up the holes with the hole in the lower leg. So this is very important to know. What I'll do here, I will go and start. So I have done some investigation inside the part. I could realize that which dimension I can take to control the position of the handle, and then I also um, dig deeper, and then realize that definitely if there is any change for this dimension, it must be incremented in 2 inches, no more nor no less. Okay, so as you can see, it is trickier. There is a rule for uh, this change, and if there is any other designer new to this design table, they need to know that there is such a rule. How we can do this restriction, how we can define that uh, this dimension can't be any dimension. There is a rule for it. Let's go forward and see how we can address um, this aspect of the design table. So if I go to insert, I need to go to table and insert a design table. So we have discussed different options here, so I won't go for it again. I just use auto create formatting, and when I insert the table, you could see that the distance for the mate is here, handle overlap. If I click on OK, you can see that the default, which this dimension is 6 inches, is here. Okay, now is the time to go and name the configuration and also set the restriction for changing this dimension. The first configuration, I will name it setting 0.02, setting 0.04. And if I highlight these two, again, I can use the functionality of the Microsoft Excel and add the 0.06, 0.08, and also 0.10 setting for the configurations, okay? And as I mentioned before, you could see that there are some rules to change this dimension, okay? And the increment for this dimension should be definitely in 2 inches, okay? So I can put a rule for this cell. So if any designer comes in and they want to do any change to this design table, they need a trigger to be able to understand that there is something going on inside the model. So again, I will take advantage of the functionality of the Microsoft Excel to put this trigger, which if I go to data and then data validation, I can set a rule for this cell that this rule can get values from the list which I define, no, from the list. So here I will put a source as 2 for this dimension, just can be 2 inches, 4 inches, 6 inches, 8 inches, and 10 inches. And if I click on OK, you can see for this cell, a set of restricted dimension is given, okay? So I cannot put any other dimension than these ones into this cell. Simply I copy this one and paste it to the other cell. I will go to paste option, go to paste specials, and from this list I would ask to paste the validation. So now I will go and change the dimension for the setting 0.02. I will set it to 2, similarly to 4, to 6, to 8, and to 10. All good. And if I just click anywhere outside this in the graphic area and I show you the configuration, it takes a bit of time. You will see now I have different configuration where the handle is positioned at different heights. Yeah. So if I just show you different setting 0.02, as you can see, it is the longest one, the longest position of the handle. And in order, it comes towards the shortest position. So as you could see how it is easy to create different configuration just by controlling one dimension, which was in this case was a distance mate. Now I'm going to move forward and add another configuration in which this type of tire is suppressed and another type of tire is introduced. Okay, so I will go and edit the design table, and this time just dismiss this pop-up. First I will name the new configuration, which is the standard one, and I will set it for the default dimension for this left-hander overlap for the distance dimension. And then what I'll do is that I want to add one more feature here, which will be changed across different configuration. Okay, so as you can see, this time I'm going to go and introduce one of the components inside the assembly. So what I can do, simply I can click on this column and double click on the feature. As you can see, a syntax has been added and the state is resolved for the default. I wanted the same for all the configuration, but this for the standard one, as I said, I don't want to have this tire, so I want it to be suppressed. Again, here, if I just put a capital S, it's identifying that this feature is going to be suppressed for this standard one. If I again exit the design table by clicking inside the graphical area, you will see that a standard configuration is added and one of these tires is suppressed. Okay, if I go over the other configurations, you can see that we have it. So I will go back to the standard one, but and this time I'm going to show you how we can suppress both of these components. In fact, they are the same components, but we have two of them. So simply I can go back to the design table. I will edit the table. And if I go over the syntax, just dismiss this pop-up. If I go to the this syntax, you can see that there is a one, there is this number one inside the bracket. If this number refers to the number of this tire as it is in here in the feature manager tree. If I just simply add 1 and 2, indicating that I want both tires to be suppressed, and just click in the graphic area, you will see that both tires will be suppressed inside the standard configuration. Okay. Now I'm going to add another type of tire to a standard configuration. But before doing that, I need to do some setup for the configurations in order to um, make it if there is any new features or components or mates added to another configuration, it won't be applied to the rest of the configurations. Let's go to right click on a standard configuration and go to the properties. Okay. In the advanced options, you can see two options. It says that whenever we add a new component to any configurations, just suppress it to this current configuration. And whenever we add a new feature or a new mate to other configurations, just suppress it to these configurations and to this specific configuration. So as you can see, these two should be selected for all of the configuration. I will go to the rest of configuration, and as you can see, first and one of them is selected, I will select the next one. Similarly for the rest of the configurations. Go to configuration properties and select both. And this time, at this point, it is easy that I can make sure that whatever change I do in this configuration, it won't apply to the rest of the configurations. So I will go and insert another component to this assembly. I will go and add a plastic tire. I want 1 and 2 of them. I will add some smart mate to this assembly, to these tires. Just by keeping the Alt key and taking this edge, you can see that some smart mate is added. So I will do the same for the other side. And as you can see, these 2 plastic tires is added to the standard one. But if I go over to the other configuration, they have the old tire. So the next step is that I'm going to add one more configuration. I will go to the design table. Just dismiss this pop-up. This called flatbed. And I want the setting of this configuration to be added to this flatbed. So simply I copy and paste them. Control C. The setting for this one. Yes, all good. So what I can do, I will go back to the SolidWorks environment, and as you can see, the flatbed configuration is added this time. And if I go to the flatbed, you can see the same setting of the same dimension of the setting 0.6 configuration is added to flatbed configuration. And this time I'm going to suppress some of the features. Beforehand, let me go and check the properties of the configuration. So as you can see, both of these options are selected. And this time I'm going to suppress some of them made for this handle and make it horizontal. So what I do, simply I click on the I right click on the handle and go to view mates position. Using the shift, I will suppress all of these mates for this flatbed configuration. And then you can see that the handle is now free to move. I will use some smart mating and I added to a smart concentric mate to the these 2 side, and now I'm going to use a coincident mate. One more time. Flip, no. I guess I need to go back to the handle and flip the concentric ones. Edit feature. All good now. So as you can see, again in the configuration, if I go to a standard, I have everything set as it was before. And for the flatbed, as you can see, the position of the handle is different. So you can see how it is easy using design control, design table to control and add so many other configuration to your assembly as the same as your part. So hope you find this webinar useful. It's not limited to the functions that I showed you. There are many more functions that you can apply to this design table and use it to control your configurations inside the assembly and part. But due to the lack of the time, we cannot cover everything. So if you go through the help of the SolidWorks, you can see so more information. Hope you find this webinar useful. If you have any question, please just drop a message in the chat box so we have still enough time to discuss it. So apparently there is no question, and I again want to thank you for your attendance and hope you find it useful, and we'll see you in the next webinar. Thank you.